Okay, so what we're going to be working on is an introduction to calculus. So what I would like you to do is to do the try this. So the try this says, here's this given function f of x equals x squared. I want you to do all these evaluations. Okay, and then I want you to also do the ones down here. Okay, so put me on pause and do that. Okay, so f of 1.9 comes out to be 3.61. F of 1.99 is 3.9601. And f of 1.999 is 3.996001. Okay, so on to the other side. F of 2.01 is 4.0401. F of 2.001 is 4.004001. And f of 2.0001 is 4.0004001. Okay, so now what I want you to do is look at your x values. Look at all the x values. Do you notice anything about your x values? Yeah, I know they're all decimals. That's not what I'm talking about. But look, we have 1.9, 1.99, 1.999. So notice these numbers here. Think of the number line. And notice that, I'm going to just draw a number line above here. Try to help you understand this. So think of a number line. Right, here's 0. Here's 1. Here's 2. Okay, so think of a number line and think of where 1.9 would be. So 1.9 would be maybe about there. And then 1.99 is a little bit closer to 2. And 1.999 gets a little bit closer to 2. So all these numbers here are getting closer and closer and closer to 2 coming from the left side of 2, right? Because we have 1.9, 1.99, 1.999, right? Those are all on the left side of 2. Now look at all these numbers here. 2.01, 2.001, 2.0001. Those are all also getting very, very close to 2, but coming from the other side. So I have 2.01 would be maybe right there, and then 2.001 would be there, and then 2.001. So they're all getting really, really close to 2. So this side is getting close to 2 coming from the right, and these numbers here are getting close to 2 coming from the left side. Now, so I have my x values. My x values here are getting closer and closer to 2. Now look at the y values. 3.61, 3.96, 3.99. These numbers are getting closer and closer to what number? 4. And look at these values, 4.04, 4.004, 4.0004. These numbers are getting closer and closer to 4. So let's write that down. So let's write down as the x values, oops, sorry. As the x values are getting closer to 2, coming from the right and the left, from sorry, as I keep I'm really close to the side here, so it keeps going on to a highlighter. From the right and left of 2, the y values are approaching 4. So this is called a limit. All right, so let's take a look at the bottom. Okay, so we have negative 3.01 squared is positive 9.0601. Negative 3.001 is 9.006001. And negative 3.0001 is 9.006001. All right, on to the other side over here. Negative 2.9 squared is 8.41. Negative 2.99 squared is 8.9401. And negative 2.999 is 8.99401. Okay, so let's take a look at the x values here. So notice my x values here, negative 3.01, negative 3.001, negative 3.0001. So those values are getting closer and closer to what number? They're getting closer to negative 3. Coming from the left side of 3. Negative 3, sorry. Negative 2.9, negative 2.99, negative 2.999. All these numbers here are also getting closer and closer to negative 3, coming from the right side of negative 3, right? So one's coming in these are coming in this way to negative 3, and these are coming in this way. So if I have my number line, here's 0, negative 1, negative 2, negative 3, negative 4, right? So negative 3.01, that's coming in this way, and negative 2.99 is coming in this way. So they're approaching negative 3. Now look at the y values. What are your y values approaching? I have 9.06, 9.006, 9.006. So these numbers here are all approaching 9. I have 8.41, 8.94, 8.99. These are approaching 9. So as my x's approach negative 3, my y values are approaching positive 9. So let's write that down. So as the x values so I'll just put as the x's, are getting closer to negative 3, coming from the right and left of negative 3. The y values are getting closer to 9. And again, that's a limit. As your x's approach negative 3 from the left and the right, the y value is approaching 9. So again, that's a limit. So let's write down the definition of a limit. All right, so we have here f of x becomes arbitrarily And the reason why it's arbitrarily, because you can use really any number, like I did up in the try this. I really kind of picked any number that my x was approaching, and I will get a y value that it will approach. Close to a unique number L as x approaches C from, that's from, either side the limit of f of x as x approaches C is L. Okay, and then it's written like this. The limit as x approaches C. So that's what we did in the first one. We did as my x was approaching 2 from the left and the right. My function, f of x, was approaching L. So in the first one, it was approaching 4. My y value was getting closer to 4. In the second one, my x was approaching -3. So my limit was 9. Okay, so when you see a limit, okay, so when you see a limit, so I'm looking at this right now. When you see a limit, this is called your intended value. Okay, so it's what your x value is approaching and your y value is approaching. If you have f of a, this is what we were actually doing in the try this. We were plugging in the number. It's your actual value. So we got actual values to come up with what is the limit. Okay, so what we're going to work on today is finding limits from the graph, and then over the next few days, and I guess a couple of weeks, we'll be finding from using the equations, but we're just going to start off by just working with the graphs. Okay, so turn the page. Okay, so here I have my function g. So I have this graph of function g, and I want to find these limits. Now, do notice it's going to be hard to see on the video here, but if you look at the worksheet that is that's on the file, well, actually, I'll try to make it a little bit bigger so you can see it. But on your worksheets, if you look at the worksheet that's posted, there are these little things right here. So this says x approaches 0, and then there's a little minus up top right there. And then this says as x approaches 0, and there's a little plus there. Okay? And that's the same thing on the ones below too. Okay, so what that means is it's telling you which way to approach the number. All right, so this says find the limit as x approaches 0. Since there's a little minus, that means coming from the left. All right, so what I want you to do is put your pen on your graph. Okay, so we're going, here is x is 0. Here's 0. There's x is 0. I want to put my pen on the graph, and I want to approach x is 0. So these are all my x values, and I'm approaching, right now I'm kind of by -2. I'm approaching -1 here. Now I'm approaching 0. As my x approaches 0, what is my y value? My y value is 4. Now I'm going to do the limit as x approaches 0 from the right. That's what the little plus means, coming in from the right. So now I'm going to put my pen on my graph. Now I'm approaching 0. Right now I'm at right here, right? I'm going from the right side. I'm at x is 2. Right now I'm at x is 1. Now here I'm at x is 0. When x is 0, what is my y value? My y value is 4. So since coming from the left and the right, coming from the left, I get 4. Coming from the right, I get 4. Then the limit as x approaches 0, see, notice I don't have any little plus or minus up here. The limit as x approaches 0 is 4. So these numbers have to be the same in order to have a limit. You have to approach the same number from the left and right in order to have that limit. All right, now I want to find here g of 0. Now this is the actual value. What is g of 0? Now remember, this is the intended value, what your graph is approaching. This is g of 0. G of 0 is actually -1. Okay, so we have the limit, what your x is approaching, what your graph is approaching, but it's actually, this here is what your g of 0 is actually. So g of 0 is actually -1. My y value is -1 when x is 0. All right, so let's take a look at number 2. Okay, so just really quickly, these are as x approaches -1 with that minus there. That's from the left. This is x approaches -1 from the right. There's a little plus there. Okay, so let's take a look here. All right, so for the first one here, the limit as x approaches -1 from the left. All right, so on the left side, put your pen on the left side. Here's -1 here. So we're approaching coming from the left. So right now here I'm at -3. Right now I'm at -2. But notice this just keeps going down and down and down. So what do you think it's approaching? It's approaching -infinity. So coming from the left, x is going to -1, it's infinity. Oh, sorry, I wrote that on the wrong one. All right, now we have to come in from the right side. Now we're doing as the limit as x approaches -1 from the right side. So put your pen on the right side. All right, so I'm coming in. So I'm at 1 here. Now I'm at x is 0. And what's happening here as I'm getting closer and closer to -1, it just keeps going down and down and down. That's also going to -infinity. So as your graph comes in from the left, it goes to -infinity. As your graph comes in from the right, that's also going to -infinity. When your graph goes to -infinity on both sides, then the limit as x approaches -1 is it doesn't exist. So you put DNE. So the limit itself doesn't exist when it goes to -infinity. Coming from either side, the limit is -infinity. But when you kind of put it together, it doesn't approach an actual number. So you just put it doesn't exist. All right, so now we're going to do the actual value. What is the actual value of f of -1? So here's a -1. My y value is 2. So f of -1 is 2. All right, so let's try one more. Okay, so before we get started, this says here the limit as x approaches -2 from the left. There's a little minus there. This is x approaches -2 from the right. And this is just x approaches -2. Okay, this says x approaches -4. This is x approaches 3. Okay, so we're going to here do the limit, the first one here. The limit as x approaches -2 from the left. Okay, so here's -2, right? So I want to be on this part of the graph. Okay. All right, so put your pen on that part of the graph. I'll use blue here. Okay, so we're coming down. So right now I'm at x is negative 3. I'm getting close to x is negative 2. What's my y value? My y value is negative 2. All right, now we're going to do the other side. So we're coming in from here. So right now I'm at x is 1. I'm at x is 0. X is negative 1. Now I'm here at x is negative 2. So what's my y value? My y value, again, is negative 2. Since coming in from the left and coming in from the right, it approaches the same number. As I'm going to negative 2, my y value from the left and from the right are both the same, negative 2. That means the limit exists, and that means the limit as x approaches negative 2, sorry, I have to squeeze this in here, is negative 2. All right, so now let's do, just erase this here. All right, so now we're going to do the limit. Now notice for this one here, the next one, I don't have a negative up top and the plus up top. So you have to make sure when we do this limit, as x approaches negative 4, you come in from the left and from the right, it approaches the same number. So let's look. As x approaches negative 4, I'm coming in from the left side. Coming in from, here's negative 4. Coming in from the left side to negative 4 here, right? Here's negative 4. What is my y value? My y value here, right? My y value here is 2. But notice what happens when we come in from the left side. From the left side, as my graph approaches negative 4, what is my y value? My y value is 3. They're approaching two different numbers. In order for the limit to exist, they have to approach the same number coming in from the left and from the right. From the left, it's approaching. From the left side, we are approaching negative 2. A positive 2, sorry. Coming in from the right side, we're approaching 3. Approaching two different numbers. That means the limit doesn't exist. So put DNE. All right, so let's try another one. So we're going to do this one here. The limit as x approaches 3. Okay, so here's x is 3. Here's x is 3 right here. Okay, so put your pen on the graph. Okay, so I'm here at x is 0, x is 1, x is 2, x is 3 here. What y value is it approaching? It's approaching negative 2. So now you have to check the other side. Coming in from this side, I'm at x is 5, x is 4, x is 3. So as I'm approaching 3 from the right, what's my y value? It's still negative 2. So coming in from the left, it's negative 2. Coming in from the right, it's still negative 2. That means the limit exists, and the limit is negative 2. Okay, so that's it, and you'll do some practice. Sorry the video is a little long. But the first part is just try to get what limits is and try to get you to understand it. So an introduction sometimes is a little bit longer than most other videos. All right, so have a good day, everyone. Stay well.